So, question 34, we've got the two boys arguing over who's best at maths. Let's see if one is better than the other. So the first thing that I've done here is to define the random variable that we're using. That is x, and I'm calling x the number of questions that twin B answers correctly. So then what is the probability distribution of x? Well, we're told to assume a binomial distribution, and there are 50 questions, and so the probability distribution of x is binomial 50p, and it's the p that we're testing. So our null hypothesis is that there is no difference between the twins, so that twin B is no better, so achieves the same mark as twin A, and the alternate hypothesis is that he's better. So there's our null and alternate hypotheses, and we're going to now try to calculate the probability of twin B achieving a mark of 76% or more. But twin B, if he achieved a 76% mark on 50 questions, actually answered 38 questions correctly. So we need to find the probability that x is greater than or equal to 38. Some calculators can actually give you that directly without having to do any calculations in addition. But my calculator will only do x less than or equal to a certain number. So I've had to do 1 minus the probability that x is less than or equal to 37. So the probability, if twin B was answering these by chance, the probability of getting greater than or equal to 38 questions correct would be that number there. And that's the number that we have to compare with our significance level. And because 0.2229 is bigger than 0.1, we have to accept H0. This is not a rare event. It would have to have a probability of less than 0.1 for it to be a rare event and for us to reject H0. So our conclusion is that twin B is not better at this test. I wonder if you got the same conclusion as me, and whether you did it in the same way. It is possible to instead calculate critical regions, but since the question doesn't ask us to do that, we don't need to do that extra piece of work. Okay, if you got the same answer, well done.